Let's have a look at the formation of a covalent bond. A covalent bond is a strong bond and it is formed by sharing electrons between atoms. Let's take a look at hydrogen. Hydrogen has no neutrons. It has only one proton and one electron, and that electron is in the first shell. The first shell is not filled. It needs one more electron to be filled. So when two hydrogens come very close together and share their electrons, then their outer shells are filled. So hydrogen is a single covalent bond formed by sharing a single pair of electrons. And this is a strong bond. Let's take a look at another example of a covalent bond. This time we'll look at oxygen atoms. When two oxygen atoms come together, they share two pairs of electrons and form a double bond between the two oxygen atoms. Oxygen has 8 protons and 8 neutrons. So the first shell has 2 electrons. The second shell has 6 electrons. It needs 2 more electrons to complete its second shell. So when two oxygen atoms come really close together, they intersect each other, they can share 2 pairs of electrons. So let's see that. You have 2 electrons on the inner shell and the 6 electrons in the outer shell. So what happens is that the electrons can be shared between the two atoms. This way we form 2 bonds. It's a double bond between the oxygen atoms. So oxygen is written as O double bond O. Let's take a look at the covalent bond that is formed to make water. Water is H2O, so it has 2 hydrogen atoms and 1 oxygen atom. And covalent bonds are present between the hydrogens and the oxygen. So here's how it's written. The structural formula is written as OHH, and these are single bonds. So let's draw the oxygen. Oxygen, as we know, has 8 protons and 8 neutrons. It should have 8 electrons. So you will have 2 electrons on the inner shell and the remaining 6 in the outer shell. We need to fill this outer shell, and so electrons are shared with hydrogens, the 2 hydrogen atoms, in order to fill the shell. So let's draw the hydrogen. You have 1 proton in hydrogen. It comes real close to the oxygen atom and shares its electron with oxygen. So there's the electron that it shares with oxygen. The same thing happens with the other hydrogen atom as well. Your 1 proton and the electron shell, and there's the electron. Here we have a covalent bond between the hydrogen and the oxygen. However, the oxygen being much bigger than the hydrogen, it tends to pull those electrons towards itself. So the oxygen, because it pulls the electrons towards itself, it becomes a little bit negative, partially negative. The hydrogen gives up its electron a little bit towards the oxygen, and so it becomes partially positive. So that little sign that you see there is partial positive charge and partial negative charge. So that's why we say that water is a polar molecule, and because it has a positive end and a negative end, and the electrons are shared unequally. And this type of bond is called a polar covalent bond because electrons are shared unequally. Now let's compare a polar covalent bond versus a non-polar covalent bond. The difference here is how the electrons are shared. If the electrons are shared equally, then we have a non-polar covalent bond. If we have electrons shared unequally, we have a polar covalent bond. We just saw the example of water. Electrons are shared unequally in the formation of water. So Oxygen is slightly negative and the hydrogens are slightly positive. So here we have a polar covalent bond because there are opposite poles that are formed in the molecule that's made as a result. Electrons are shared unequally. That's what we need to remember. Let's compare this to a nonpolar covalent bond. We just saw a double bond between oxygen atoms, and here both oxygen atoms are equal in size and they share the electrons equally. In nonpolar covalent bonds, there is no charge in the opposite ends of the molecule and the electrons are shared equally. It's because the electrons are shared equally that you don't have the charges in the different parts of the molecule. Since water is a polar molecule, it is a great solvent. It allows salts such as sodium chloride to dissolve. So how does that happen? Sodium and chloride break up into sodium ions and chloride ions, and water molecules surround them in an interesting way. The oxygen part of the water molecule, which is partially negative, tends to face the sodium. On the other hand, the chloride ion is surrounded by water molecules on the hydrogen side. The hydrogen atoms are partially positively charged and so they face the chloride ion. In this way, the salt dissolves in water. Let's recap what we know about covalent bonds. Covalent bonds are strong bonds. They are formed when electrons are shared. Electrons are shared equally or unequally. When they are shared equally, nonpolar covalent bonds are formed. When they are shared unequally, polar covalent bonds are formed. Some examples of molecules that are held together by covalent bonds are methane, hydrogen, oxygen, and water.